So welcome to our first lunch talk in this spring quarter. We will have another lunch talk in a couple of weeks, but typically we have these Brown Media Innovation Institute lunch talks once a month or so, always when we find interesting speakers. And today we have here dear friend of Brown Institute's, Professor Larry Birnbaum from Northwestern University in Chicago. He's professor both in computer science and in journalism, so he has basically two hats, even though they're invisible today. And he's not only a professor, but he's also a co-founder of Narrative Science, which used to be a small startup doing like automated journalism, basically like automated production of financial news and sport news. And it used to be small, but now it's big. They have, 60 or 80 employees already.
I don't think that's huge, but yeah.
Well, it's much bigger than a couple of years ago. So he's co-founder there and also the chief scientist. And my name is Tanya Aikamoto. I'm the deputy director of the Brown Institute for Media Innovation, also a postdoctoral fellow at the institute. I'm joined here today with our director, Professor Birnbaum, who is over there, and Professor Anne Grimes, who is the Associate Director of the Brown Institute, and our Program Manager, Kelly Yilmaz. Please have a seat and grab some food. We're about to start. And Larry will talk today about how we can find narratives and stories in big data sets.
Great.
So please join me in welcoming Larry and kicking the talk.
Thank you very much.
Thanks.
I appreciate the opportunity to be here. Thanks for inviting me. And I'm going to try and rush through the beginning because I know everybody wants to get to the automatic narrative generation stuff, but I do want to give you a little bit of a history of kind of where I'm coming from and how this started. My research partner, Chris Hammond, and I started about 15 years ago thinking about this as a communication device. This is a dialogue box, really, and we came to realize that it's easier for a rich man to get into heaven than it is for you to get the contents of your brain through the eye of this needle and out into the world. It's a miracle that it ever works because of the lack of context. So where we really started was in contextual search. Our first solution, built by our PhD student, Jay Budsick, really Chris's student more than mine, about more than 15 years ago now, was a system called Watson. So my first takeaway from this project, by the way, is never name a program something that a much more famous and important program is going to be named later. But what Watson did is it automatically analyzed the contents of a document that you were editing or looking at, and it would find stuff on the web for you or in any data source really automatically that was relevant to your story. For example, in this instance, you're building this document on the jazz in American culture, and you're finding all this stuff about jazz here that would be kind of grist for the mill. And it was a fantastic program. It was fast, it was automatic, and it was better than human. And by that I mean that if you actually gave this system a document and asked it to form queries, and then you wrote queries yourself based on the document and looked at the results, you would judge the results from the machine better than your own. And I'm not going to go into the mechanisms by which it worked. I think they're sort of it was a nice stringing together of some garden variety sort of NLP and text analytic mechanisms. It didn't really work. And actually, this was a big discovery for us because we realized that we were doing exactly the same thing that everybody else in IR did, even though we didn't think of ourselves as IR people, which was we were using similarity as a proxy for relevance. And of course, the minute you think about this, you see that it can't quite work because the most similar document to a document that you have in your hand is that document, right? So in fact, that tells you right away that to actually be interesting or useful, a document has to be similar in certain respects and dissimilar in other respects. And that got us beginning to think about kind of dimensions of dissimilarity that would be interesting for a contextual search system to provide, that it couldn't just be... Now, if I were a statistically minded person at this point, I would have looked for the golden donut, somewhere around, and there are people like Jaime Carbonell at Carnegie Mellon does this, and I think many other people do as well, of sort of stuff that's kind of has the right sort of statistical level of similarity. That's not how I roll. So we actually got interested in sort of semantic distinctions of sort of how to prime the pump. In other words, rather than relying on the statistics on the size of the internet to bring back interesting things, can we actually sort of think about dimensions of querying that would be natural for a human being to do that would actually provide the right information? Bernd, of course, remembers this project. We actually did the same thing that we did with Watson for video and built a kind of cool system called Beyond Broadcast to sort of automatically provide you with information about a video you were watching. And we did this for a bunch of Food Network examples. So here's Alton Brown talking about corn dogs, and you're getting sort of some obvious things here. And actually, I think recipes are always really great for a lot of reasons to think about semantics. But if you think about it from a retrieval point of view, if I'm showing you a lasagna recipe, and if you actually go to a search engine and type lasagna recipe, you're going to get like 1.5 million hits or 5 million hits or something. And you don't need 5 million lasagna recipes. If I'm showing you a lasagna recipe already, what else should I show you at that point? I mean, this is an intuition pump, so say anything. Anybody.
Cannelloni.
I'm sorry?
Cannelloni.
Right, so related recipes but that are different in certain ways. What if I were going to show you other lasagna recipes?
Vegetarian.
Okay, there we go. So now we're into the right thing. We're into like, there are dimensions like we want a vegetarian lasagna recipe. We want quick and easy for a crowd. We want classic lasagna, vegan, low salt, low fat, low cal. And actually, if you go to a search engine that does search completion, like the one down the road, and you type lasagna recipe space L, you'll actually see all these completions. So statistically, people are asking for these things, but I think the point of this exercise is that you don't really need that to know what dimensions matter, and that was very interesting to us to think about. I'm not going to talk about too many of the projects that we did in this vein because I do want to move on to other sort of more modern things that we did, but here's an example where we tried to build a system that was kind of a crude analogy machine based on these kinds of ideas. And the idea was that given a story like this, where Oracle tried to buy, and you can see the age of this was 2006, tries to buy MySQL, we'd get stories about IBM trying to buy some other open source software company. So the idea was that big technology company tries to buy open source software company, but the different companies were involved. Here's another example. This is a story about Israel's use of cluster bombs during the 2006 Lebanon war. And actually, if you gave this to Watson, you'd get 50,000 other stories about that. You give it to this system, and what you got was stories, about like US use of cluster bombs in Afghanistan, or NATO use of cluster bombs in the Balkans, and so on. So you'd get sort of different actors doing similar things in different settings. And the idea was to provide, again, this is where we began to think about providing more context as the model for what we were trying to do. I think we had moved from, hey, show me an alternative, to show me an alternative that will help me understand my original thing better. And that was kind of a nice move for us. Another example, by the way, that previous one was done by my student Jiawei Liu, who's now at Google. This is called Tell Me More. It was another system. What it did is it tried to find additional information in a news story based on, given a news story you were looking at, find other facts that were not in that news story that were in other news stories on the same topic. And so we needed to find, and this is kind of a lot of what I like to do, is to try and find cheap syntactic proxies for new information, because in general it's very difficult to identify new information. And so we came up with the idea of new numbers, new named entities, and new quotes. So that's really all the system does. It goes through these other news stories on the topic and finds things. So for example, here's the story about the disaster in the Gulf a few years ago, and here's some additional actors in other news stories that are not in this news story from the Chicago Tribune. Here are other news stories involving different numbers or data that are not in the original story, and here finally are additional quotes that were not in the original story. And so the idea was this is a relatively simple way of actually identifying new information. We actually did a version of this where we took these paragraphs and stitched them into the original story to see if we could, instead of actually putting them off to the side, if we could actually just kind of cobble together a story. I'm not showing this, but it worked pretty well. I mean, in fact, they read hard, but it turns out news stories often read hard anyway. So the fact that there was kind of a little bit of a disfluency between one paragraph and the next wasn't necessarily noticed in this context. So I thought that was interesting. And then finally, this is an example of a thing we did more recently on this vein, and then I'm going to sort of pivot. It was a system called stakeholdertweetback. What it did is it would look at a news story, find people and organizations mentioned in the story, find out their verified Twitter handles, and then look to see what were they saying about the topic of this story on Twitter. And what we've just recently done, actually, is we're starting a thing called the News Context Project, where we've built a kind of a, this architecture you've seen repeated over and over in the last 5 minutes. We've sort of built a sort of simplified version of that as a toolkit that's actually been sort of built into a Chrome browser extension. And so we've built about 5 different projects that have a sort of a very similar flavor. One, for example, given a news story, will go to all the Reddit threads that actually talk about the topic of that news story, which we've decided to call Read It. I don't know if that's a good idea or not, but anyway, and we do a number of these other kinds of Twitter projects, and we're going to be releasing that as a toolkit for other people to use probably in the next, I hope in the next 3 months or so. It's not quite ready yet, but when we do, I think it'll be a simple way for people to build these kinds of contextual adjuncts to news and other kinds of information stories. So kind of pivoting a little bit, and I'm sorry, this talk is a little bit of a, we run a lot of projects, and so I love the projects, really, and I wish I had a grand theoretical vision to give you, but instead we're going to talk about, the projects we built. I hope that's okay. We've been doing a lot of projects, actually, based on social media, of course, based on Twitter, since it's open. This is a project we did for a few years ago for the 2012 presidential election. Bernd, have I showed you this before? I don't know if I may have done. Yes, the usual bug, but that's okay. Maybe if I do this, it'll. I'm sort of Let's see. I need to find the my preferences, don't I? And change it. Is somebody a better multimedia person than me? Come on.
What are you trying to do?
I'm trying to actually, yes, thank you. I'm trying to fix this. Anything about any suggestions here?
Look on arrangements, just to see, it's mirroring, so.
No? I'm sorry?
Maybe to tech displays.
This one? Thank you. Maybe that will work.
Yep, center.
Okay, well, let's see if this works. Thank you very much. I should learn how to use this someday. Okay, so, well, it's a little off, but that's okay. It's because of this thing here. So this is a thing we built to predict who you would vote for in the 2012 presidential elections based on your tweets. And these are the terms that were most predictive of being an Obama versus a Romney voter in the 2012 presidential election. As you can see, Obama voters were profane, and Romney voters were talking about, I guess, their enemies. I guess that would be the way that I would try and characterize this. We thought that was pretty funny. There's kind of a story there, actually. The hashtags, I think, make a lot more sense, and the websites that you went to. But we can put somebody in now. If anybody wants to, here, let me sign in. I apologize. I don't myself tweet. I only have login credentials so I can run our applications. So, just a second. We will be happy to. Are you a journalist, though? You are a journalist.
Yeah.
Well, I'll use you, but I want you to know that journalists we get wrong a lot of the time because they talk about things. Here, we'll just do Bill Gates first. So, for instance, we predicted that Bill Gates will vote for Obama or would have voted for Obama based on his use of these terms. And it's about 85% accurate for most people. There's a set of people for whom it's less accurate, but it's reasonably accurate, actually. What's your...
It's my first name, T-A-N-J-A.
Uh-huh.
A-I-T-A.
That's it?
Yeah, that's it.
Okay.
Okay.
T-A-N-J. So it predicts that you would have voted, if you could have voted,
Exactly.
for Obama, and because of the use of the terms equal, equality, and so on, same sex. It was. I thought it was a kind of a cool system. Anybody else, or are we done with this one?
It's kind of heartening to me that we get journalists wrong, because
Well, you know why? Because so we had so we did a thing for the Norwegian. I'll show that one next. We did a thing for the Norwegian. This I did for Andrea actually. So we'll, hopefully we can get to that in time. We did a thing for the Norwegian election as well, and we had some Norwegian journalists come into the lab, and you know that journalists talk about, because this is not really getting sentiment. This is just sort of doing. Let's see if I can get this thing to come up here. So this is like the Labor Party, I assume. A lot of these terms are in, and I apologize for the screw-ups in aspect ratio and so on. This, I assume, is the Christian Party. It got her as a hard right, voting for the hard right-wing party, which she was pretty upset about, but it turned out she talked about crime a lot in her Twitter feed because she reports on crime. And it turned out that, you know, being somewhat obsessed with crime turned out to be using those words turned out to be predictive of voting for the hard right party in Norway. I mean, maybe that's not surprising. And so I think since it's not really getting what you're saying about these things, but in some sense the topics that you're talking about, it got them wrong, and I think it would tend to get reporters wrong because they are probably talking about things that are not of personal interest to them necessarily as, does that make sense? Yeah. So I think that was really what was the, that was kind of the thing there. So I hope that's okay. I keep tantalizing you with that one. We'll get to it eventually. So I don't want to go too much into this. We built a lot of recommendation systems based on social media. I mean, we did a book recommendation system that had about 60,000 people use it. It actually works in a bunch of languages. If you tweet in Arabic or English or Portuguese, it only recommends books in English. But it's about 15% of the people who have used this system actually click through to Amazon to look at the book. We don't know how many people buy it because we couldn't set up at the time an affiliate marketing scheme in Illinois because Amazon and Illinois were fighting over sales tax, so we couldn't really get our act together in time to do that. I will show this one though, and I'm going to show it because I think it's pretty, I hope I'm going to show it. This is a news recommendation system that we built, and I'm really kind of messed up again. This is.
Go back to that display. You can set it.
Yeah, apparently so.
Well, you can also just make the browser
Yeah.
drag the screen over.
Right. Yeah. Okay. Yeah, we'll just do that. Thank you. Bless you. The simple solution is always the best. This is a system that actually will do personalized news recommendation for you, or actually, again, you can use anybody's Twitter handle so you can sort of get, in some sense, aspirational news. So these are the news stories that we're recommending to Bill Gates right now, and based on his tweets. It's not what Bill Gates is reading. We have no idea what Bill Gates is reading. This is based on what he's talking about on Twitter. These are the news stories that we're recommending to him. And what I guess the reason why I want to show this project is because it's really brain dead simple, and I'm kind of proud of it because I feel like we reduced social media-based recommendation to its bare minimum. This system was written by 4 undergraduates, including probably 1 journalism and 3 CS students, in 10 weeks last fall. I mean, the version we're looking at now is the hardened version that was kind of redone by our developer at the lab, but the original version was done in 10 weeks and it consists actually of 50 lines of glue code. Because here's all this system does. Go to an RSS feed, the ones, whatever ones you want, get URLs of news stories, throw them into Twitter Search API, find 5 to 125 people who have tweeted out that link, okay? Grab 100 to 500 of their tweets, mush them together into a document, throw those documents into Lucene or Elasticsearch, and then when somebody else comes in and wants recommendations, labeled by those URLs, when somebody else comes in and wants recommendations, get 100 to 500 of their tweets, mush them into a document, throw that into Lucene or Elasticsearch. It automatically does nearest neighbor, okay, based on what search engines do. It'll use TF-IDF. So it's not even really a machine learning system. It'll bring back a bunch of people who are close matches in terms of the contents of their tweets. take the URLs associated with those, and those are the news stories that you're going to recommend. That's all there is to this system. There's nothing there. And I love that, actually. I love it that there's nothing there. I'm really kind of proud of that fact. I think that if you actually were, I mean, there's two questions about a system like this. One, how well can you do with these data? In other words, can these data really do a good job of supporting news recommendation or music recommendation, because that's what we're going to do next, actually. And the second question is, could you do better with these data with a much more highfalutin algorithm? And I'm sure the answer is yes, that you could do better. So the question is, how much better can you do than this? And I don't know, any thoughts about that? Are there any machine learning experts here? I don't know. I bet you could do like 20% better, or maybe 10% better. But the point is, you'd be working pretty hard for that final 10 or 20%, and this system doesn't do anything. So I think we're probably going to release a kind of recommendation toolkit for non-programmers. I'm thinking that we should actually do something for I don't know, like maybe something for like CS 101 type classes where people have to actually, I think rather than building, I think this would be a fun project, build a shoe recommendation system or something like that based on social media. I think people would enjoy that. Anyway, so that's that project. Yeah. Come on, Sparky. Excuse me just a second here. Okay, so we did the same thing for local things. I'm not going to show this, but we did exactly the same thing for local bars, restaurants, and cultural venues based on your tweets. So give me your Twitter handle, and here we're using people's tweeting out, I just ate at, O'Toole's bar, I just had a hamburger at O'Toole's bar and I loved it, or something like that. Actually, we're using Foursquare check-ins. But again, it's the same thing. So we can recommend things in any city in the US plus Barcelona. We can do recommendations for you. This is a system I'd like some advice about this system. So this is a system that my student Jason Cohen and I are doing called Attitude Buzz. And what it's trying to do is we're trying to use geolocated tweets to figure out attitudes towards gays and lesbians. And what we're doing is we're finding tweets that mention the word gay or the word queer or other words less nice than that. And assuming it works, let's see if we can get it to work. Huh? Winnetka, Illinois? Yeah, thank you. Did you still live in Winnetka? No. Okay, yeah. Yeah. Well, actually, it doesn't seem to be really. I apologize. But anyway, what you'll do is you get a kind of a heat map of the Bay Area, for example, and if you could see it, what you would see is that it's mostly gay-friendly, except there are parts on the west side of the Bay that are less gay-friendly. And anecdotally, that's probably what people would expect to be true. I don't know whether it really is true, and so there's actually an interesting question of how to actually think about something like this. What we did is learned a special-purpose sentiment analyzer so this is what it actually would look like for Chicago. I'm sorry about how crappy the display is, but the idea was to build a special purpose sentiment analyzer, and the way we did that is we needed labelings of the tweets. Are they actually homophobic or are they gay friendly? Interesting problem, how to find those data. We eventually decided to take the following expedient, take known gay friendly neighborhoods, for example, Boys Town in Chicago, and just assume that the tweets coming from that neighborhood are positive, which introduces some noise, obviously, but we don't really know how much noise.
Is it like the more blue it is?
Yeah, bluer is better, and lighter blue is bad, and yellow is less good. And actually, there's no red in Chicago, but there is red in the East Bay. Yeah, on the other side of the bay, right? There's definitely red in Oakland and Fremont. You can find red zones, or Jacksonville, Florida. So if you look at different places, and again, it corresponds to what you think anecdotally about it. So we're trying to think about what to do with this. We're thinking about the idea of actually building a system to quickly do this kind of special purpose sentiment analysis with respect to kind of trending hashtags around very fraught events like the situation in Ferguson, Missouri. Can we find neighborhoods where we know people will have a certain attitude and use those as the training data to actually quickly build a thing like this. I'm going to skip this one. So
I'm thinking business-wise or research-wise, which is the
this,
yeah.
I think this is just research. I don't.
Research.
I don't. I mean, if you have a business idea, I'm welcome to. I'd be happy to listen to it. But I don't. I mean, This is something we were doing for because we were interested in it. I mean,
Yeah. Well,
I mean-
of course, like things like Airbnb, you would kind of be interested in the kind of vibes in the neighborhood.
yeah, yeah. I mean, actually, I thought about this for real estate. Like, do I want to buy in a neighborhood where there's a lot of homophobic people? Probably not. So I think that for real estate, I mean, you could actually think about understanding the attitudes of the neighborhood, or alternatively, unfortunately, maybe I would like to move into that neighborhood. So I mean, there's these things always cut lots of ways, actually.
Yeah, but research-wise, obviously, kind of maybe serving the neighborhood and seeing how well what kind of correlation you get.
Yeah,
between how-
absolutely.
That is, I guess that should be kind of done.
Look, I think, look, there's a whole thing that can happen that would be, the whole filter bubble idea of parasites. You could imagine a life bubble that could make it even worse. I mean, I can definitely imagine a model that says, I've looked at your social media, you should live in Winnetka, Illinois, and you should go to the following bar, and you'll meet people just like you know what I mean? And I think that's actually something to worry about, so for sure. I want to switch gears now and talk about the work we've done on automatic story generation, and because this is really the most exciting stuff. Chronologically, it's not the last stuff I've been working on, but if I put it in the middle of the talk, I can never get to anything else. So I did want to show you some of the other things we're doing at Northwestern right now. At some point, we came to the realization that narrative science, or the automatic generation of stories, is really about the big data revolution, and that is that there's no point in gathering and analyzing a lot of data if you cannot convey the data and the results of that data in a way to people that's meaningful to them. And I think it's fair to say that the way that people have mostly thought about doing that is through visualization. And so visualization has become such an important research topic because that's a clear way to convey data to people, maybe in a way that's more meaningful than tabular data, all right? But we think that there are other ways stories have been around at least as long as charts and graphs have been around. So I think that they're kind of a cool model. Here's some data from a hockey game in the Rio Grande Valley, ironically. And here's the story. Here's the story that our system wrote from that. The Rio Grande Valley Killer Bees were firing on all cylinders against the Laredo Bucks, and when the final buzzer sounded, Killer Bees emerged with a 6-3 win. So we write a lot of stories like this. We mostly do not write, so maybe the way to, going back to the big data theme for a second, so this is a sort of admittedly we actually showed one that's particularly bad, but this is kind of your basic idea of a big data display, and this is really what we want. We want to take things like this, and we want to turn them into this, okay? And that's what we do. So the company Narrative Science does write quarterly earnings previews for Forbes.com. Here's one for Red Hat. Here's one for Apple. You can find these on the web very easily. If you search for Narrative Science and Forbes, you'll find the stories that we're generating for Forbes, the quarterly earnings previews, and we generate a lot of these stories. When you think about it, obviously financial data, when we first actually thought of doing this, I remember very vividly the conversation, and Chris and I were talking about it, and we were like, what content verticals should we actually try to write stories in? And I sat and I said, well, I think we need places where the stories are not too complicated and the data are available. So it's got to be either sports or business, So we actually originally did sports, which I think was a great choice at the university because it's accessible and exciting, and actually the narratives in some ways are better narratives. They have a lot more temporal structure to them very often. But the reality is that the company is focusing on financial stories because that's where the money is.
Little League doesn't pay.
We love doing Little League, though, actually. We do Little League, too, and we love doing it. But so we do sector reporting, for example. I don't know what happened there. So we do this kind of thing, So why stories? So this is what you could get, obviously, tabular data. Here's a nice graph that somebody might show you. And if you understand what you're doing, like if you really understand this, you'll know how to read this graph and understand what the point of this graph is. or we can generate this for you. Okay? Sales have increased. There has been a steady decrease in margins, which should be a cause for concern. In other words, if you looked at those two things and saw that they were both going up but diverging, if you knew enough about finance to understand what that meant, you wouldn't need this story necessarily. Okay? But a lot of people will find a lot of value in this story because it's going to pull their attention to the factors in the data that they need to understand. Okay? And that's kind of the premise. That's kind of the premise of our technology. Stories pick out what's important, they connect it, they find out what's critical. You can't take a wall of data and turn it into a wall of text. I mean, people actually ask me a lot of times, well, how does it generate the words? That's the least critical aspect of this technology. The issue is not how to say it, the issue is what to say. I mean, figuring out what to say in the morass of data that you're given, that's kind of what we have to do. They explain things, they provide context, they make the data meaningful. We did our first prototype at Northwestern, and oh, it's not here. Oh, that's delightful. I usually like to show this live. It's still up and running there, actually. It takes these data. It was called Stats Monkey. It was written by me, Chris Hammond, Nick Allen, and John Templon. Nick and John were actually Medill students. And Nick is still with the company. John is at BuzzFeed now. So these are the box score, the line score, and the play-by-play data from this game. And it can generate this kind of nice story. Down to their last out, Griffey saves Mariners. The Chicago White Sox had the Seattle Mariners, I'm sorry, down to their final out. But Ken Griffey came through, oh boy, with a single to drive home the winning run in the Seattle's 1-0 victory in a 14-inning marathon on Wednesday at Safeco Field. And since it knows that Griffey was the most important player, it goes out and finds a photo of him and sticks it up here. So this is not a bad story. And we actually had a sports reporter at the Toronto Star take apart a story that he wrote about a Major League game, and then a story that our system wrote about the same game, and he thought they were pretty comparable. In fact, he felt that we'd done a few things better. By we, I mean the machine. And that was a very exciting, that was kind of a really exciting, sort of a gratifying thing for us. And this was really gratifying too, actually, when we got this little kind of call out in XKCD. So we still haven't done that. We should do that, actually. I'm going to tell you a little bit about how this system works. I'm sure you're saying, well, what does it do? I mean, a couple of things to say. First of all, that this is not fundamentally a machine learning system. You can think about the idea of taking, for example, a company like Google might think about taking 25 million sports stories and 25 million box scores and sticking them and running machine learning and trying to learn how to write those stories. I don't think that's going to work. And I don't think that's going to work because these stories have a tremendous amount of internal structure, and this is not really what machine learning is about right now, necessarily, that kind of thing. What we do is, to be able to write a story, first of all, is we need a model of the rhetorical structure of the story. And then second of all, in other words, you need to understand what are the different sections of the story trying to say, what kinds of data do they need to say those things, and what kinds of characterizations of those data would be relevant at this point in the story for this purpose that this section is serving. I hope that makes sense as a kind of a model for what we do. So for example, a baseball game recap, the first part of the story is who won the game and why. The second part of the story is the pitching. The third part of the story is other interesting stuff. And what I mean by that is if somebody hits a home run, you must talk about it. But if it did not contribute to the outcome of the game, you don't talk about it in the first section, okay? So I hope that makes sense. And each section has appropriately relevant narrative characterizations of data that are relevant to that portion of the story. So for example, the last part is interested in outliers. Okay, you want to look at things that are unusual events, okay? But that's not what the first part is about. The first part is not about outliers. The first part is about important turning points and how to talk about them. So for example, in a sports story, we'll have ideas like a comeback victory or faded at the end, okay? In business stories, we'll have things like low-hanging fruit. Or an example we talked about this morning, if you want to characterize why a metric changed, you need a sort of narrative characterization of that. For example, the company's doing less well, its revenue is down. People might characterize that as death by 1,000 cuts. In other words, a lot of little things are going wrong, and that's why this company is doing worse, okay? That's different from there's one major problem that they have, okay? And those are very interesting patterns of data that people would, especially when you have a name like that, like death by 1,000 cuts, those are very important signifiers of kind of data patterns that people have found important enough to name, and we pay a lot of attention to those. Low-hanging fruit is a very similar kind of concept. You know, what's the one thing I can do that'll make my life better today, you know what I mean? So spotting those kinds of things. Yes?
Each of those terms or semantics of each of those events or
Right.
things are encoded into your system, like.
Right, as data patterns, that's correct.
So they're not discovered automatically, I guess. So you put these rules and then the system will.
No, those might be discoverable automatically, by the way. That's the kind of thing, learning a phrase like that or a term like that is something that I could imagine a machine learning system doing. I don't know if it could put together a whole story. We don't currently do that. I could certainly imagine doing that. I mean, the critical issue is actually expressing these things at the right level of abstraction. You don't want to have to you know, I don't think it's a secret to say that at the company our struggle is to get away from domain-specific things up towards levels of abstraction where it's not so much that we're getting rid of semantics, but the semantics is expressed abstractly enough that it applies to lots of content verticals, business and sports and so on. And that's really a lot of the technical work at the company is around raising that level of abstraction and making the thing more configurable, right? As opposed to kind of configuring it for any particular content vertical. And I should say something about where we're going with that. I mean, once we have gotten far enough along down that path, I mean, our goal is to actually build a toolkit that we can release to people to actually configure these things themselves. Because we're not going to, this is a good example of a story we did pro bono with ProPublica about 52,000 public schools in the United States. Scott Klein was our collaborator on this project. Some of you may know him. And here's a story that our system wrote about the high school in the town I live in, Evanston Township High School. It tells you a little bit about how many kids, for example, are qualified for free or reduced price lunches versus the state average. And what it basically does is it goes on to talk about the socioeconomic level of the families that the school serves versus the how well it does in AP classes, because that was kind of what ProPublica, that's the story angle that ProPublica was interested in, right? How well you were doing, you know, compared to kind of the population you were serving. I mean, again, to go back to Winnetka, Illinois, the school is great on all kinds of metrics, but of course the population it serves is very wealthy. So Evanston Township High School is a much more diverse school, and so that was kind of the point of these stories. We did 52,000 of these with ProPublica. They helped us get the data, and we configured the system. But what we'd love to do is have a toolkit that we can give to them so that they can do this themselves, because we're a little startup company. We can't really afford to do a lot of pro bono projects like this. We were happy to do this one. You know, I kind of rushed through, which is good, I guess. That's fine. We'll have plenty of, yes, question.
How do you compute the goodness of fit between the articles and your templates?
Templates. So I'm not allowed to use the word templates. We had this discussion once. I said templates once in a meeting, and then afterwards it was like, you can't say that because if you say that, people think Mad Libs. So I'm obliged at this point in the conversation to say if by templates you mean relatively abstract, dynamic, and recursive structures, yes, we're talking about templates. So, I'm sorry? Yeah, schemata would be a. So what was your?
So how do you compute the goodness of fit? Like for some, even each article you have multiple.
Yeah. So actually, we haven't really. At this point, there's enough separation between the kinds of patterns we have that it's not an issue. We have done some experimentation in thinking about dispositions to explain the data in one way versus another way, and how that would change the kinds of stories that the thing would write. So, changing thresholds. For example, there are people who write sports stories who like to find somebody to blame. I mean, their job is to find a goat and explain and say why the goat is responsible for this loss, you know? And so we've done some experiments with sort of fooling around with thresholds to make you more likely to find that kind of explanation. We haven't done anything so technical or sort of abstract as thinking in general about the relations between these thresholds for these different things and sort of the how much ambiguity there is in matching them. So far in the stories we're writing, there isn't a terrible amount of ambiguity. But I could definitely foresee a point when we got sophisticated enough and we had enough patterns where that would be an issue. So that's a really good question. Thank you.
I have a question.
Sure.
Supposing that you have to use this system for Spanish news, how much dependent is the architecture of the system on the language?
Virtually not at all. And actually, we would love to do more non-English stories. We're not really doing that yet. There are some configuration issues right now. Give us about another 2 years, I would say, maybe another year. That's related to this configurability issue as well. We would love to be able to say, because in principle, the thing is we're not going to generate a story in English and then use a statistical translator to turn it into Spanish. It'll be directly rendered in exactly the same. Yeah, exactly.
The data part from the process.
Yeah, we're not there yet, but give us another year or two. Absolutely. Absolutely. I mean, it makes complete sense, doesn't it? I mean, generate the story in multiple languages, of course, yes. Please, yeah. Yeah.
Okay, thanks. So does the system need like structured data, like numbers and figures?
Structured, numerical, and quasi-numerical data, that's correct. If there's unstructured data, we need to structure it before we can write a story about it.
And does the machine like knows a lot of patterns of stories? Do you teach them to?
So we don't teach them. We configure the story to have these. We configure the system to have these rhetorical structures and then the associated kinds of data patterns for each section of these rhetorical structures. So it doesn't learn them, but it does have to know them, obviously, in some sense of know. Does that make sense? Yeah. Hi. Yes. No, I'm sorry. He hasn't.
So for like the Prof example, how much sort of configuration time did that take, and sort of where are you hoping to get that to as you roll it out as some end users?
So a lot of the issue right now, frankly, is getting the data lined up. I mean, as everybody who's had to work with data knows, it's not as nicely lined up as you'd like it to be. And so kind of wrangling the data and getting it kind of normalized and sort of focused appropriately it was probably a great deal of that project in particular. There was some configuration time. I really don't know off the top of my head how long it took. If you're asking me what we'd like to get it down to, 2 hours. I mean, that's what we'd like to get it down to, or 20 minutes. I mean, I think that's our goal, you know.
Scale, how much larger is it than 2 hours right now if we were to?
At least one order of magnitude larger than that, and maybe more sometimes, depends. But at least one order of magnitude larger than that. So it's more like 2 days than 2 hours, I would say, and sometimes 2 weeks. Yes.
In scientific papers, what we write normally, this experimental section.
Yeah.
Numbers.
Yeah. We've thought about that.
Coming close to like feeding in numbers and it creates like experimental.
Yeah, we've thought about that actually. Yeah, it's not the right. It's not the highest demand application, but we've definitely thought about it. Yeah, because it certainly touches home to us as well. If we were, absolutely, it's an issue. So it would be fun. I mean, again, that's a case where I think if you're asking us where we're thinking about health data, crime data. We've done some crime stories, actually, economic data. We've done stories for the National Health Service in the UK. We wrote narratives around hospitals based on hospital data that they provided us with. So that's a good example of an application area that we're doing. I see that this particular deck, because I got deck, how's that for an old word? Because of like the screw ups before, it doesn't have we did do a social media story, which I'll just talk to. So during the 2012 election, we did social media. We gathered social media data on the Republican presidential during the presidential primary, following each of the primary candidates, and we wrote stories about them each day based on these data, and I'll be happy to show people afterwards, but this was kind of a little experiment we did. So we had one that said, I think the title was, the headline was, Newt Gingrich gains traction on Twitter with hot button issues being taxes and character, actually. So we had a topical analysis of the tweets, and we talked about where, how Newt Gingrich was doing on Twitter, and then we talked about, in particular, the topics that people were talking about on Twitter about him. So again, we took the unstructured data and structured it using some statistical categorizers. And then we actually used this sort of standard sentiment analysis to say, what did people think about him? And actually, in this particular day, everything worked and it lined up properly, and it said that they were negative on character issues, mostly positive, but negative on character issues. And then it selected a tweet that it knew was negative. I mean, it didn't know what the tweet meant. This is actually, this is to the point about unstructured data. If you have a query that's a pretty specific query, you can find something and the system won't know what it means, but it's probably the right thing if the query is specific enough. And so it came back with this pretty slanderous, I mean, it wasn't legally slanderous, but a pretty slanderous tweet about Gingrich came back as the one it selected, saying, for example, I think her name was Mama Vickers Writes, and then you see what she wrote, which was sort of negative. It was a pretty cool application, actually. I was really excited about it.
We have time for one more question before we finish. So anybody? Final question?
Is it time to, okay, because I know you guys have to run out, right? Okay, I have a few more, that's okay. I have a few more examples to show, but people can leave if they need to leave, by all means, please do, yes.
So the eventual objective is to make it fully automatic. Are you considering this kind of human intelligence inside and a helping aid for that I want the first paragraph to be this kind of a...
Look, I think that, the goal of people in...
writing.
I hear you. The goal of applied AI people like me is typically full automation, because that's the thing that scales the best. I mean, if you think about it for a second, there's a reason why AI and crowdsourcing in some sense are the two big themes right now, because those are the things that handle scaling. We are certainly not averse to having human intervention if somebody wants that kind of application. We don't do that right now. Our customers want the ability to scale endlessly and effortlessly without human intervention, but I can certainly imagine that there would be many applications where a mixed initiative kind of system would be the relevant, a useful and relevant way to go. So I'm not against it. From a research perspective or even a technology perspective, pushing towards the most automation is sort of pushes you towards the most progress. So I think that's the thing there. Should I just shut up now, or what do you want to do?
If you're going to finish, if you have a couple of more slides, so let's...
Yeah. So like here's the, like for example, here's the, so the company Gamechanger actually has an iPhone and Android scoring app, and if a coach or a parent scores the game, we get the data. So we write probably 5 or 10 million of these every year. A superb effort by Kat Morris lifted Richmond Rampage to a 6-0 win in 7 innings over Blue Ridge sudden impact on Sunday at Darden Toe, Charlottesville. So we write stories like this based on Little League data every single day. They're read by anywhere from 0 to 8 people, but that's the point. I mean, it doesn't really matter how many people read them because they're written, I mean, and actually speaking of a thing I'd like to do in multiple languages, I think this is really be great because I think there's a lot of, grandparents who might not speak English who would be thrilled to see reports about their kids. I think we're doing youth basketball now as well as baseball, yes. Well, this is so absolutely. I mean, this is a huge issue. I mean, if a coach or a parent especially wants to slant the game to make it look like their team won, then then that's going to be an issue. I mean, we're taking, for our commercial customers, obviously, validation is a huge issue. For these people, I mean, it's an important application. We love it, but we don't worry about it that much. I agree, it's an issue. You can imagine. You can imagine certainly data problems either due to dishonesty or incompetence. No question about it, okay? That's a place where crowdsourcing might be a very good thing. If multiple people upload the data and there's some discrepancies, thinking about how to resolve those, I think that's a great problem for people to think about, actually. I think that would be a great Brown Institute thing. Or maybe I should do it at Northwestern, come to think of it. It would be... A couple of quick things. We have some self-service applications. If you want to try this yourself at home, if you have a Google Analytics set up on your website, you can give us your credentials, and we'll write stories based on your Google Analytics data and send them to you weekly. And also, we'll do the same thing for Twitter. If you are the kind of person who worries about their impact on social media, I'm not such a person, but I know many people who think about how many people are following them and how to communicate with their followers and how to extend their followers and so on. This will actually generate a narrative about your Twitter data that will help you understand your relationship with your followers on Twitter and what you can talk about that works with them. Here's an example of a Quill Connect story for Chris Hammond, my research partner, who's a co-founder at Narrative Science, which discusses what he and his followers tweet about, who are the most influential among his followers, and so on. So looking at your history, misspelling, that's great. You are most focused on technology, science, and politics. Your followers are tweeting about the same topics as you are, but with a little less focus on technology. So there's an example of that kind of thing. If you are looking to increase reach, you could try using hashtags that are more likely to be picked up. For example, the most retweeted of your followers have utilized Payments 2014 and FOST in their recent tweets. Well, this wasn't that recent. Quill Engage, again, does the same thing for Google Analytics data, and again tells you a little bit about the about what that is. And again, you can do this all by yourself at home, and these are free right now. So please try them out, and if you have any feedback, I'd love to hear about it. Yes, Anne.
How come you don't tweet?
So can we take that offline? Okay, thank you. Because I do have something I want to show before we go. I know that I'm running late, and I beg your indulgence. First of all, I want to thank my research partner, Chris Hammond, our wonderful students, the National Science Foundation, Knight Foundation, and Google, Narrative Science for making it real. I want to actually show something now that Andrea, who's here, had helped to pay for. She actually got us, she got us the Google Glass that we needed to do this thing. So this is actually a kind of a really fun project, and I hope it's not going to be too loud. Do people have time for this? This is about 5 minutes or so. I'm sorry?
If you show the beginning of it?
Yeah.
Yeah.
So let me explain what it is a little bit, and the genesis of this. My daughter's actually was a theater student at Northwestern, and she wrote a play her senior year where she didn't actually write anything. What she did was she curated, I guess that's the current term of art, excerpts from the Craigslist forum Missed Connections, which I gather is pretty raunchy. I personally don't follow it, but the nice ones are things like, I saw you on the L and you were wearing, a blue jacket and I thought you looked really cute and blah, 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 and here's my phone number. So she actually strung all these things together, and when she and I were talking about it, I realized it was very similar to some of the things that Chris and I had been doing in terms of putting together narratives, which are not like the things that narrative science does, where the system really understands what it's talking about. These were systems where you'd kind of put things together and you didn't quite understand what you were talking about, but they had the right thematic flavor to them in some sense. I hope that makes sense, that we were putting together sort of, we were looking for pieces of text on the internet that already existed and repurposing them to build a larger narrative structure, where the system understood the larger narrative flow but did not understand the details of what it was saying. I hope that's clear, okay? That's very different from what narrative science does. And the minute she said this, I said, she and I realized that we could take the things that Chris and I had been doing in the lab and we could actually apply them to theater to build kind of real-time theatrical experiences where you would sort of automatically build that kind of script out of stuff you found online and present it to actors, improv actors, to actually read. Because we had done some stuff with text-to-speech previously which sucked. I mean, because one of the things that, this is actually a big theme I know everywhere, let the computer do what it can do and let people do what they can do. You know what people can do really well? They can interpret a line. I mean, actors can interpret a line, but they don't. But the machine actually has a little bit of difficulty with that, even if it's retrieving the line. I know this sounds goofy. See, the original version we just did using big screens. Because Andrea was very helpful, we got these Google Glass, and she's never seen this before, so I'm happy to be able to show this today.
Good evening, and welcome to the first public running of TheaterBot 3000. David.
Oh, come on. Really? Huh? No, I didn't. Let's try again. I don't know what I did here. Come on, Sparky. Well, maybe not.
Let's thank Larry. This was
Yeah, all righty. I'll show it to you in a second. Thank you very much.